These are the lecture notes for Chapter 2 on basic chemistry. We also have the next chapter, Chapter 3, is also on chemistry, but it's going to be on the chemistry of organic molecules. So it'll be focused more on the chemistry that we see in biology, the chemicals that compose living things. But this chapter is on basic chemistry, which you need to understand a lot of the concepts in biology. We'll try to keep it focused on, just the chemistry topics that you really need to know. We aren't doing a whole course in chemistry, but you just need a little bit of chemistry understanding. So we'll go on then to, there we go. All right, so there are 4 sections in Chapter 2. There's a section on the elements, a section on molecules and compounds, the chemistry of water, and then acids and bases. All right, so a lot of this is going to be review, I hope, for you. The definition of matter. So when we study chemistry, we're studying matter, and matter is anything that has mass and takes up space. So, sorry, I'm trying to get this highlighter working. So matter is anything that has mass and takes up space, meaning it has mass and volume. And there are 4 states of matter, 3 that we really deal with in our everyday lives: solids, liquids, gases, and then plasma is a form of matter that's found in the sun and other stars. So all matter is composed of elements. So an element is the purest form of matter, and we find a list of the elements on the periodic table. So in chemistry class, if you took a chemistry course, you might have to learn most of the elements on the table. But for us, you just need to know a few of them. And the main ones that you need to know are these 6 elements, and you can learn them by the acronym CHNOPS. And they are carbon, which is the symbol for carbon is a C. The symbols are all listed up here in the acronym. Hydrogen, the symbol is H. Nitrogen, the symbol is N. Oxygen, the symbol is O. Phosphorus, the symbol is P. And sulfur, the symbol is S. Okay, the smallest unit of an element, or the smallest particle of an element, is an atom. So we can talk about one particle of carbon, for example, is a carbon atom. So an atom is the smallest part of an element. And atoms are composed of 3 main subatomic particles. They're called protons, neutrons, and electrons. Inside the nucleus of the atom, which is the most central part of the atom, we have protons, which are positively charged, and then neutrons, which have no charge. So what I would want you to know about the subatomic particles is their location and their charge. Protons are located in the nucleus, and they have a positive charge. Neutrons are located in the nucleus and have a neutral or 0 charge. In the electron shells are electrons, and they have a negative charge. And here's a table that shows you all of that information. The charge of the proton is +1. It's located in the nucleus. The neutron is 0, located in the nucleus. Electron is -1, located in electron shells. And what you can see up here in figure B is you can see the atomic model of, this is actually for the element helium. Helium has 2 protons, 2 neutrons, and 2 electrons. All right, so each element on the periodic table is represented by a symbol. It's either 1 or 2 letters. For example, hydrogen is H, sodium is Na, carbon is C. The atomic number is also in the box on with the element, and it's going to be the number of protons. That's going to tell you the number of protons in that atom. The mass number is going to tell you the number of protons plus neutrons. Excuse me. So, for example, here we have the symbol for carbon is C. Its atomic number is 6 and its mass number is 12. So what we can tell by that is we can tell that the number of protons, I'm sorry, let me fix that. The number of protons for carbon is 6. Okay, so I'm going to try this again. I'll write it more slowly, I guess. Protons equals 6. The number of electrons is always going to equal the protons unless it's an ion, which is an atom with a charge. So we're going to assume here that this is a carbon atom that does not have a charge. So the number of protons is 6. The number of electrons will also be 6. That way the number of positive charges is 6 and the number of negative charges is 6. So overall, positive 6 and negative 6 gives you 0, which means the atom has no charge. The atom itself is neutral. So the first two subatomic particles in this element, carbon, are proton. The number of protons is 6. The number of electrons is 6. And then we have the number of neutrons. And we will calculate the number of neutrons by taking the mass number and subtracting the atomic number. So that's also going to give us 6. It's not always going to be the same number of neutrons. You always need to get the neutrons, you always need to subtract the atomic number from the mass number. Okay, now on the periodic table, there's a little bit of information here on the periodic table. I'm not going to highlight any of this because you probably won't have these questions on your test. But basically you have the columns are called groups and the rows are called periods. The columns are called groups, and atoms within the same group have similar chemical properties. And you can see a portion of the periodic table here. One thing that I will tell you is the mass number is actually listed here as the atomic mass, which is a decimal. What you would do is you would round it. So again, if you had to find the number of neutrons for carbon, you would say 12, take away 6 is 6. Or for neon, you would round that atomic mass 20, and you'd round it to 20, and you'd say 20 take away 10 is 10. While we're here, we'll just do one example. Let's see. Let's just do phosphorus, okay? Forget that I highlighted silicon and aluminum. We're just looking at phosphorus right now, okay? So when we look at phosphorus, we see that the mass number is round that 30.97 to 31, and the atomic number is 15. So if we want to find the number of protons for phosphorus, oh my goodness, sorry about that. All right, try this again. If we want to find the number of protons for phosphorus, the number of protons is going to be the same as the atomic number, which is 15. Oh my gosh. So let me try this again. Okay, protons is 15, electrons is also 15, and the neutrons is going to be 31 take away 15, which is 16. All right, so I'm not doing great with the mouse, but anyway, for phosphorus, just to repeat this, for the number of protons for phosphorus is 15, electrons is 15, and neutrons would be 16. So that's another example that you can use. Okay, let's move on. Down here, what we're seeing here are examples of isotopes. Isotopes are going to be atoms that have the same numbers of protons, the same atomic numbers, but different mass numbers. So they have different numbers of neutrons. And that's going to change their mass numbers. And so here's carbon-12. Carbon-12 has 6 protons and electrons, and then when you subtract 12, take away 6, carbon-12 has 6 neutrons. Carbon-13 is going to have 7 neutrons, and carbon-14 is going to have 8 neutrons. That's the difference between these isotopes, is they have different numbers of neutrons. And sometimes isotopes will give off radiation. So carbon-14 is an example of a radioactive isotope. We can use isotopes, radioactive isotopes in medicine. Here you see, in picture B, you see a woman getting a PET scan. And then you also see an example of a thyroid scan, which uses radioactive iodine. The radiation, when you give the person, when you inject the radioactive iodine into the person, it accumulates in the thyroid because the thyroid has a lot of iodine. The hormones, thyroid hormones, are composed of iodine. So everywhere that radioactive iodine shows up, you can get an image of it. And it's the same thing here, except they use, I believe it's radioactive glucose in the PET scans. But the bottom line is you can use radioactive isotopes to do scans, and you can also use radioactive or radiation to irradiate fruit so that it won't spoil as quickly. This is showing a person who's getting radiation therapy probably for like cancer. So we can use radioactive isotopes in medicine for sure, and even in preserving our groceries. Okay, so for about electrons and energy, the main thing is that, let's move to the next page. What we're going to talk about is where electrons are located, because it's the electrons, and especially the ones that are furthest away from the nucleus of the atom, that determine the chemical properties. So when we talk about electrons, the closest electron shell to the nucleus is called the first energy shell, and it can hold up to 2 electrons. After that, if there are more electrons, the additional shells can hold up to 8 electrons. So, and this is called the octet rule. The octet rule, octet meaning 8, states that the outermost shell of an atom is most stable when it has 8 electrons. So the outermost shell is also called the valence shell. And this is the valence shell, or the outermost shell, is the part that it's the electron shell that determines what the atom is going to be able to bond with. Okay, so the octet rule states that the outermost shell is stable when it has 8, unless the atom only has 1 shell, and then it's stable with 2. So make sure to read the exception. And so what this means is, for us, in biology, we're really just going to be concerned with understanding that atoms are going to lose and gain electrons in order to fill their outermost electron shell. So it says here, the number of electrons in an atom's valence shell determines whether the atom gives up, accepts, or shares electrons in order to acquire 8 electrons in the outer shell. So atoms that have their valence shells filled with electrons tend to be chemically stable. And all of those in group 8, the noble gases like helium and neon, those already have filled outer electrons, or outer electron shells, or valence shells. But all the atoms in all the other groups are chemically reactive. They're able to react with other atoms to form compounds and molecules. And that is because their valence shells are not filled. Okay? So, for example, if we look at hydrogen. Hydrogen only has 1 valence shell, but it's only got 1 electron. So it would really need 2 to be stable. So hydrogen is not stable. Carbon has 4 in its valence shell, and it needs to have 8 so it's not